All right, here's some basic stuff about exponents before we get into the topic, solve exponential equations. The first thing you need to know about equations that have exponents is what you call the thing that's being raised to an exponent. So for example, if I have x squared, the x in this place is what we call the base. The thing being raised to the exponent is called the base. And then the exponent, you should know what that is right there. Okay, so you have a base and an exponent. Now, if there's a number you want to multiply by the base being raised to an exponent, that's called a coefficient. Anytime you're multiplying a variable, whether it has a visible exponent like a 2 or the invisible exponent 1 or any other exponent, if you want to multiply it by something, I'm just going to make up a number, say 3, that is called the coefficient. So those are all words that you need to know. Coefficient. All right, so you've got a coefficient, you're multiplying by a base, and the base being raised to an exponent. So what else do you need to know about exponents in order to solve these? Well, you need to know that if you have some number a, being raised to some exponent like whatever, x, so a to the power of x, and that's equal to the same a, the same base, but to another exponent, say y. If these two things are equal, well then x and y have to be equal to each other. In that case, x would be equal to y. Why is that useful? Because if I give you a problem and I say that 3 squared is equal to 3 to the power of x plus 1, well, these are both 3. The base for both of these is 3. Here the exponent's 2, and here the exponent is x plus 1. So therefore, 2 must be equal to x plus 1. And now we have a very simple equation that we can solve for x. We can figure out what the x is. So let's take a look at the very first problem we have for solve exponential equations, and we can see how this stuff applies. We have 2 to the power of 5x plus 3. So our exponent up here is this whole expression, this little binomial up here, 5x plus 3. The word binomial means expression with two distinct terms like this, binomial. So if this is our exponent up here, we want to know what x is. What we have to do is see if we can write 4 with a base of 2 to some exponent. In other words, 2 raised to the power of what is 4? You might know that in your head. It's 2 to the power of 2. So this is what I might write. I might say that 2 to the power of 5x plus 3 is equal to 2 to the power of 2. I just wrote exactly what it says in our equation. I just didn't write 4. I wrote 2 squared. 2 squared is 4, so it's the same thing. Well, since 2 to the power of 5x plus 3 is equal to 2 to the power of 2, I can write the equation that 5x plus 3 is equal to 2. And now I can solve this equation. I can subtract 3 from both sides, and I can get 5x is equal to 2 minus 3 is negative 1. And now I can divide by 5 on both sides to get my x by itself. X equals negative 1/5. And so that's my answer. And that's what this is right here. Okay, well, what about this one? It's already set up so that we have two bases that are the same. 6 to the power of 5x minus 7 equals 6 to the power of negative 9x minus 4. So these two binomials have to be equal to each other. This big exponent in parentheses has to be equal to this one because they both have a base of 6 and they're both equal to each other. So I'm just going to go ahead and set those up right now. I'm going to say that those two binomials are equal to each other. So I've got 5x minus 7 is equal to negative 9x minus 4. And now let's solve. Well, I'm going to get rid of this 9x because I can't have x's on both sides. And if I add 9x to one side, I'm going to add 9x to the other. So now I have 14x minus 7 equals negative 4. Let's not forget that there's a minus in front of that 4, so it's negative 4. Now I can add 7 to both sides, and I get 14x equals negative 4 plus 7 is positive 3. Now I divide by 14, And I get x equals 3/14. So that is my answer. And there it is. Okay, let's try another one. Now, this is just like the last one. 7 to the power of all that stuff equals 7 to the power of all that stuff. So this binomial, 3x plus 6, must be equal to this binomial, negative 6x minus 2. So I'll just write another equation that says what that says. 3x plus 6 must be equal to negative 6x minus 2. And this is a very similar looking problem to the last one. Again, I can't have x's on both sides, so I got to get rid of either the 3x or the negative 6x. I always like to get rid of the one that has a coefficient that's farther left on the number line. Negative 6 is less than positive 3, so I'm going to get rid of this plus 6x. Or, excuse me, the negative 6x by adding 6x, by saying plus 6x. I do it to one side, I do it to the other. 3x plus 6x is 9x, so I have 9x plus 6 equals negative 2. Now I can get the x's by themselves by subtracting 6. If I do it to one side, I do it to the other. So that 9x equals negative 2 minus 6 is negative 8. Now I divide by 9, and I get x equals negative 8/9. And where's that? Negative 8/9 right there. Okay, so this one's a little different. Drag the explanations used to solve the given equation to the correct sequence. So we're just doing the exact same thing we did in the very first problem, just with different numbers, and we're dragging the explanations to it. So before we actually get to the dragging part, let's just solve it. What would I do for this one? I've got 5 as the base on the left. I need to make sure that the right side is written with that same base. I need to write it with a base of 5. So what I'm going to do is I'm going to say, okay, let's rewrite the entire thing. 5 to the power of 6x minus 9 equals 125. If that is our equation, this is a base of 5 with this binomial as an exponent. This is not a base of 5. It's 125 with an imaginary exponent of 1, an invisible exponent of 1. So what I can do is I can say that 5 to the power of 6x minus 9 equals 5 to the power of what? 5 to the power of what is 125? Well, 5 times 5 is 25, and 25 times 5 is 125, so that would be 5 to the third power. 5 to the third power is 125. So now I can say, all right, well, 5 to this exponent equals 5 to that exponent, so those two exponents must be equal to each other. 6x minus 9 equals 3. Now I can add 9 to both sides. And I get 6x equals 12. And now I can divide both sides by 6. And I get x equals 2. So now I go ahead and I fill in what we just did over here. What was the very first thing we did? We changed 125 to 5 to the third power. Where does it say that? Subtract 9 from each side? No. Equate the exponents of the equation? Oh, not quite. That's what we did here. We said that the two exponents were equal. So that's the second step. Divide each side by 6, add 90. Here it is. Rewrite 125 as a power of 5. And that's what it is. When you rewrite 125 with a base of 5, you're saying 5 to the power of 3. So we are writing as a power of 5. Next, we equated the exponents. We said, hey, these two exponents have to be the same. 6x minus 9 must be equal to 3. Then we added 9 to each side, plus 9 plus 9. Then we divided by 6, divide each side by 6. And that will be the answer. Okay, so this is another one just like the other one. We got the two bases already set up for us. We have two bases of 7, so 10 plus 8x equals 6x plus 3. This is just solving two, real simple equations at this point, as long as you understand the concept of two identical bases that are equal to each other have identical exponents. So let's go ahead and write this. 10 plus 8x must be equal to 6x plus 3. Then I subtract 6x from both sides. And you know, if you want to take a shortcut, we can see already that the x's are going to be on the left side. So let's go ahead and just subtract the 10 right now. We can do that from both sides, because that way we're going to get rid of the 10. We'll have the x's on the left side and the constants on the right side. The constants are the the numbers without any variables or anything have a constant value. 3 always means, 1, 2, 3. It always means that many, more than 2, less than 4. 10 is a constant value, and we're subtracting. So over here we have 8x minus 6x is 2x. And over here we have 3 minus 10 is negative 7. These canceled out and these canceled out. Now I divide by 2 on both sides and get x equals negative 7 halves. Okay, don't freak out because they're fractions. The base, in this case, is 1/8. Does it matter? When I talked earlier, did I say, well, the bases, if they're the same, then the exponents are the same, but only if the bases are whole number? No, it doesn't matter what the bases are. This base is 1/8. This base is 1/8. These two things are equal to each other, so their exponents must be equal to each other. It doesn't matter if these both say 1/8, or if they both just say 8, or if they both just say 1, or if they both say x, or if they both say y, or if they both say pi. Whatever the bases are, as long as the bases are the same, if you have two things that are equal to each other with the same base, then their exponents have to be the same as well. So I can go ahead and write that 2x, which is the exponent on the left, must be equal to x plus 11, which is the exponent on the right. It doesn't matter that it was 1/8. Don't freak out because it's a fraction. Subtract x from both sides. 2x minus 1x is 1x. And those x's are gone. And just have 11, and that's the answer. That's the easiest problem we've done so far. But some kids get scared because they don't like working with fractions. One, you shouldn't be scared of working with fractions in the first place. And two, in these problems, it doesn't even matter what they are. Okay, here's another one. We have 36 to the exponent of x minus 2 equals 216 to the exponent of 5x. Now, this one's a little trickier. And the other problems where the bases didn't match up, like these bases don't match up, we were okay because we just took the number and we put the exponent that it would be. But this one already has an exponent. So what do? We're going to have to use a little bit of concept, a little bit of math. Let's make sure that we remember exactly what's going to happen here with the 216. If I've got 36 to the power of x minus 2, I want to write 216 as the same base as this, as the base of 36. But can I do that? You have to think about it. Does 216 come from 36 to the something power? Well, it's going to be pretty hard. 36 to the second power is way more than 216, right? I mean, this 36 times 36 is going to give us way more than 216. So both of these bases are going to have to change in this case. I know that 36 is 6 squared, okay? 36 equals 6 squared. Just forget about the problem for a minute. Just think about 36 is 6 squared. And what is 216? 216, can I write that with a base of 6? And that is 6 cubed. 6 times 6 is 36, and 36 times 6 is 6 cubed. 36 times 6 is 216. So if I can rewrite 36 with a base of 6, and I can write 216 with a base of 6, then I can get the bases to match up. But they already have exponents, right? 36 already had an exponent of x minus 2. And the 216 already had an exponent of 5x. So what do we do to solve that? Here's what you have to do. If you want to turn 36 into 6 squared, it looks like this. 6 squared, but then this whole thing is getting raised to x minus 2. Well, if you have a base with an exponent that you're raising to another exponent, you multiply those exponents together. So I can write 6 squared to x minus 2 like this. 6 to the power of 2 times x minus 2, like that. And that means that 216, which is 6 cubed raised to the power of 5x, can be written as 6 to the power of 3 times 5x. I'll write that in parentheses. So those are the two problems. So if you have to change both bases and they have new exponents, they already had exponents, multiply the new exponents by the old ones. So now, since they both have a base of 6, they both have exponents, I can write these equal to each other. 2 times x minus 2 must be equal to 3 times 5x. And I can solve. 2 times x is 2x. 2 times negative 2 is negative 4, so minus 4. And 3 times 5x is 15x. Now I can subtract 2x from both sides. And I can get negative 4 is equal to 13x. And now I can divide both sides by 13. Right there. And I'm going to get negative 4/13 is equal to x. And that is this one right here. All right, well, that's a whole bunch of these problems. I hope that's enough. If you have any other questions, feel free to email me and I can help you out some more.